Welcome to another video on numbers and specifically looking at multiples and factors. This is for the GCSE 9-to-1 specification for mathematics, and this does apply to both AQA, Edexcel, and also any of the OCR papers as well. This topic and subtopic that we'll be talking about, multiples and factors, applies to both the higher and foundation tier papers. So the first thing that we're going to be looking at is multiples. So what are multiples? Well, multiples are numbers that something or another number can be multiplied into. For example, if you want to find the first 5 multiples of 4, you'd basically want to look at the first 5 times table of the number 4. You'd want 1 times 4, which is 4. You want 2 times 4, which is 8. 3 times 4, which is 12, 4 times 4, which is 16, and 5 times 4, which is 20. And because you just want to find the first 5 multiples, you are only going to stop at the 5th times table, or the 5th multiple of 4. So what these values I've written down here on the right is essentially the first 5 multiples of 4. So the first 5 multiples of 4 are 4, 8, 12, 16, and 20. Those are the first 5 multiples of 4. And that's what we mean by multiples. So 20 would be a multiple of 4, 16 is a multiple of 4, 12 is a multiple of 4, 8 is a multiple of 4, and 4 itself is a multiple of 4. So these are the first 5. Now, any number can have an infinite amount of 4s, as long as if you divide it and it becomes a whole number of that number, it will be a multiple. For example, you can have the number of 400. The number 400 is a multiple of 4, because if you were to divide 400 by 4, you'd get a whole number, which is 100. So therefore, 400 is a multiple. You can do that with anything. 24 is a multiple of 4, because if you divide that by 4, that would give you the value of 6. So therefore, 24 is a multiple. So again, the only way of checking if a number is a multiple of another number is simply by dividing. Okay, it is by dividing. Okay, that's the only way. For example, if I'm given a random number of 1025, and I was told if that is a multiple of 5, and obviously we can tell that it may be a multiple of 5, and it will be a multiple of 5 simply because it ends with a 5. But those are it's not always going to be as simple as that. The only correct way of telling if that is a multiple of 5, if it is indeed a multiple of 5, we have to divide that value by 5. So if we do 125 and then we to divide that by 5, we'd get 205. Now, I've simply solved this because it's an example I've thought of before, and I know the value will be 205. You would have to do the bus stop method or any sort of division method that you know in order to find out if that truly is the case. So, is 1025 a multiple of 5? And the answer it is yes, because this number right here is a whole number. So yes, is it a multiple of 5? Yes, it is. Now let's look at a different example. Let's look at another example. Say I was given the number 169 and told if this is a multiple of, say, 3. Is it a multiple of 3? Well, we again, unlike the previous example, we can't look at the last digit. We can't just simply use that kind of method to see if it really is a multiple or not. Again, the solid way of finding out if that number, 169, is a multiple of 3. Now, the only way is division. So I'm going to do this bus stop method anyways and see if it works. Some of you may know different other methods of division, but I'll just be using the bus stop method. So how many times does 3 go into 16? Well, it can go in 5 times, but the answer of that will really be 15, because 5 times 3 is 15. So you minus 1, you get 9. And then 9 carries over. So how many times does 3 go into 19? It goes 6 times, but essentially you're left with 1 here. So when looking at this, when you do 169 divided by 3, you get 56 with a remainder of 1. Or you can do the decimals and it's just 3, 3, 3, 3, 3 reoccurring. Okay, so 56.3 reoccurring really. So is this really a whole number? No, it is not a whole number. It is not a whole number. Therefore, if 169 does not divide into 3 properly, it is not a multiple of 3. So is 169 a multiple of 3? No, it is not. It is not a multiple of 3. Because when you divide 169 by 3, you do not get a whole number. And that is essentially how you check if a number is indeed a multiple of another number. So if we look at other numbers that aren't in the times table, I'm not talking about what numbers from 1 to 12. What if we wanted to find multiples of much larger numbers, or numbers that we just simply don't know the times table for? For example, 14. We don't really know the 14 times table by heart. Well, at least most people don't. I'd be impressed if many of you actually do. But if you wanted to find the multiples of 14, it's simple. You're just going to have to multiply them by however multiples you want. So if we want to find the multiples of 14, there are different ways in which we could do it. We could use the multiplication way, or we can use the addition way. There's 2 essential ways of really finding multiples, and it's multiplication and addition. Let's deal with the multiplication method. As shown before, just a little reminder, it's, if we're going to do this as simple, we do 1 times 14, that would give us 14. If we do 2 times 14, that would give us 28. 3 times 14, that'll be 42. And we'll continue on and on. So that is one way of finding out the multiples of a number. It's just simply by multiplying them in order. But if we want to do it in the addition way, we'll have to do it in a sequence sort of method. So for example, we start off with 14. 14 is a multiple of 14. We'll have to add another 14, which will give us 28. And then we'll have to add another 14, which could give us 42. And then we'll have to add another 14 again and again and again until we find, and there will be essentially an infinite number of multiples, but you will usually be given a limited number of multiples to find out. So that is one way of finding out multiples, addition and multiplication. Now moving on to factors. So what exactly are factors? Well, factors are numbers that can be divided into something or another number. Okay? Again, the best way of explaining this is through example. What we have in factors, and what you will be primarily asked in the exams and in papers, are factor pairs. Okay? So what are factor pairs? Factor pairs are pairs of whole numbers that can be multiplied together to make a number. It sounds a little long, but it's essentially simple. If we look at this example, find the factor pairs of 36. Now that will be a question that you may be asked. Find the factor pairs of 36. Now, unlike multiples, usually when it comes to factors, and pretty most of the case, actually almost all of the case, when it comes to finding factors, there are always a limited number of factors of a number. Okay, unless your number is the infinity itself, there will always be a limited number of factors. So this question, find factor pairs of 36, essentially means find two numbers that multiply to make 36. Pretty easy. So if we just start off here, like I've written down, 1 times something will give you 36. So what times something will give, 1 times something will give you 36. And if we do 36 divided by 1, what do we get? We get 36. So we've immediately identified a factor pair. 1 and 36 are a factor pair of 36. Okay? The next thing, let's move on to the next number. If we go to 2, 2 times something gives you 36. To find that out, we do 36 divided by 2, which is 18. Again, we've just identified another factor pair, 2 and 18. Let's move on to 3. 3 times something gives you 36. Well, if we know from the times table, 3 times 12 gives you 36. And that is another factor pair discovered. Let's try the 4. 4 times something gives you 36. Again, from the 4 times table, we know that 4 times 9 gives you 36. That's another factor pair discovered. Let's try 5. 5 times something gives you 36. Odd, isn't it? There's nothing in the 5 times table that actually values 36. The closest is really 35. And that is because 5 times 7 is 35. So is this really what we're looking for? No, nothing. So essentially, nothing really goes in this thing. There's nothing. You could do a decimal point, correct? Because when you have 36 divided by 5, what you get is 7.2. And be crucial of the 7.2. But does that make it a factor pair? Essentially it does, but at the same time no, because factor pairs have to be whole numbers. Okay? They have to be whole numbers. So these two, 5 and 7.2, are not factor pairs of 36. They are not factor pairs of 36. Okay? So now let's look at the next number, 6. Well, we all know 6 times 6 will give you 36. And they're both whole numbers, therefore they are both factors and hence factor pairs. All right, let's move on to the next number. 7 times something gives you 36. Well, 7 times something gives you 36. Well, if you were to divide 36 by 7 to find that missing number, you'd get a really long decimal of 5.1428, etc. Essentially, it's not a whole number, so that is not a factor pair, and therefore 7 is not a factor, and neither is 5.1428, and so on and so forth. These are not factor pairs. In fact, I'll put a little cross next to the pairs that aren't factor pairs. Let's move on to 8. 8 times something gives you 36. Well, to find that something, you do 36 divided by 8, which would give you a value of 4.5. Again, not a whole number, therefore this is not a factor pair. Let's move on to 9. 9 times something gives you 36. Well, we know from the 9 times table that 9 times 4 gives you 36, so that's a factor pair found. But we already found a factor pair earlier before that was involving 9 and 4. And it's this one over here, right here. The 4 times 9 that we see. So we've already found that pair. So why are we moving on? There's no need for us to continue. So if I move on to 10, I guarantee you we probably won't find any more factors that we haven't already discovered. And any factors that we do find aren't going to be whole numbers of 36 and therefore aren't considered factors. So let's look at what we have already. In fact, there's a point in which you can identify when you've reached your limit of factors, when you've discovered all the possible factors that you can find. And it's at this point right here, when we found 6 times 6 to be a factor of 36, to be factor pairs, sorry, of 36, that's when we hit the limit. Because essentially, if you look at it in terms of the values of these factor pairs, they actually go around, not including the 5 times 7.2, they actually go in a sort of like a U shape in terms of their value and in order. We have 1, 2, 3, 4, not 5, but we do have 6. We have 6 again, 9, 12, 18, and 36. So everything in this U, this arrow that I'm pointing, is all the factors of 36. Those are the factors. So we both found the factor pairs and the factors of 36. So again, what are the factor pairs of 36? Well, it's these ones right here. I'm going to rub off the ones that aren't factors of factor pairs. So this, in this U of arrow over U that I've drawn, are factor pairs of 36. So let's find, so if we were to list all the factors of 36, this is what we'd write down. We write 1, we've got 2, we've got 3, we've got 4, we do not have 5, because as you remember, that was not a factor. We have 6, and we have 6 again, but we do not write 6 again, okay, because we've already identified 6 being a factor of 36. So although, yes, it does repeat, it is not a factor that you need to repeat writing in a list. So when it says list the factors of 36, as I've written right here, you just want to write that number once. So we have 1, 2, 3, 4, 6, 9, 12, 18, and 36 itself. So those are the list of factors. So how do you check if a number is a factor of another number? Again, it's simple, just by division. A lot of the methods in which we identify whether something is a multiple or a factor of another number, it is usually by division. And it's the simplest way of identifying if a factor is indeed, if a number is indeed a factor of something. So if you wanted again to look at if 5 is a factor of 110. If 5 is a factor of 110, it's simple as 110 divided by 5, which would give you 22. So the number is a whole number. Therefore, it is a factor. So 5 is indeed a factor of 110. And that is the one way of finding out if a number really is indeed a factor of another number. Thank you for watching. If you found this video useful, don't forget to like and subscribe, and to subscribe to stay tuned to any more videos that I will be putting out, and tutorials for GCSE mathematics. For now, I'll be going through the topic of numbers, but sooner or later in the future, I'll be going through other topics such as algebra and statistics. Thank you for watching.